forth. Because we know we're going to get a difference in potential in each spike because of the way we're going to arc the wheel and the way we ground the poles. Okay, going back to this portion of the wheel, you'll notice that what I did was I took aluminum and boxed these in after we bound the magnets up. Because when you get a mast that's this heavy, these are 1 inch thick and probably weigh a pound each or 2 pounds each. What we did was we took straight metal and put it in the press, and we bonded the aluminum and then screwed it to hold this in a V-cup, so that the force coming outward, it can't come through the V.
Right.
Okay. Anyway, this is me cutting welding rod and shoving it down through this core. Now this core was a little bit tricky because if you see this ridge right here on this bobbin, you had to cut wires that are inset in between these two ridges. So you had to put them in first because they're not quite as long as these. So you had to fill the full space of the coil. And then of course after these are forced in that space, they're bonded in, they're glued in. And they're glued in the bottom where the coil's inset into the wood.
Which particular coil is that?
That's the biggest coil.
In the center?
Yeah, you can see it's the biggest coil because you have this plastic here.
Right.
And you can see the metal shield's already on.
Right.
It's already bonded, and you can see that it's not tuned yet.
Right.
Because it's not spread out.
Right.
Okay? In this position in tuning, the magnetic field's going to jump. It's not going to swing. It's going to try to just curve over like this. Okay, and when you bend these down, the magnetic field's going to swing out bigger. Because what we want to do is we want to force the zero out of the center. We want a neutral point real big in the center. So that there's no conduction when the magnet comes across. Because we're going to use the impulse technology that we talked all along about to pulses. Okay, as I said, this is exactly what's inside the machine, and these are the hookup wires to the rectifiers for the back pulse. That captures it, right?
Right.
And that goes back down to that capacitor that you see in the machine. And this is the input to it where the power is going to come in.
Right.
So that's going to be tied right here, and then the wires are going to come out here and come through a hole, which you can see in the machine. And that's the switch. That's the Bedini coal switch that's going to generate this little bitty spike to switch these. And that's the number of turns. 2,206 turns of number 18 wire, every one. That's a pretty good one because you can see we're hooking up the wires.
Right.
Okay, in this picture, you can see that we're hooking up generator wire coming out of here and input wire to get the little impulse spike. Right. And that's going to be triggered by this device, which is already hooked into the switch in this red and white and black wire that's coming around here and ending up at the hull. Okay. In this picture here, David Luke is machining another one of these timing plates for smaller magnets because we found that using these bigger magnets that we overlapped the fields that we wanted to have work for us. Better picture of it. Here's a little bit better picture of it being very close to finished. So anyway, Pat, This was for Tom Bearden.
Mm-hmm.
Happy birthday, Tom.
Yeah.
And here's your machine.
I'm sure this is the best birthday present he could get, probably.
Hope so.
Yeah,
Because
it
it's-
validates all his years of work.
Yes, it's right there in front of everybody.
Right.
It's metered. Nobody touches anything. You can look at all the wires. Everything's on the top exposed. You can watch the battery. By the way, this is at 43.8 right now.
Yeah.
So it's almost at 44 volts, which is,
That's skipped up 6 volts.
yes, just like that.
Yeah.
And that is what I want to tell everybody is energy from the vacuum if you do this right.
Yeah.
So,
Yeah, it definitely vindicates
yeah,
old Tom's,
it vindicates
validates
his
all
life's
his
work
words. Yeah.
in free energy, or what he terms free energy. It isn't free
Right.
in the term that, because it costs to do all this.
Right.
So,
But you're not on a meter.
but I'm not, right, I'm not on a
You're
meter,
not on an
and I'm not burning gobs amount of fuel
Yeah.
to turn this mass. See, right now, this could be pumping water for me.
Yeah. Yeah.
So in the end, Pat, whether it's aluminum, wood, whatever, cardboard, if that's all you had, it would do the same thing.
Yeah. 44.
Yeah. So happy birthday, Tom. You can see them, they're half-inch buttons.
Oh, okay.
They go across the switch, and see these dots? Here.
Okay, yeah. I
That's
can
on
see-
the north pole.
Yeah, yeah.
Okay, so when a dot comes across this pole, it switches on. And when the coil collapses in the re-gauge mode between the metal, it sucks it into the next thing, which adds the torque.
So this is sucking it around, right?
Yes,
Yeah.
yeah, in their pie shape, see them?
So that's the radish thing?
Yes.
Yes, that's the radish thing. Yeah.
Yeah, that's a Radis motor.
Yeah. That's the radish motor right there.
Right there, that's a Radis
So you have
re-gauging
about
motor.
8 different motors running in one.
Yeah, you have to put them all together. You have to put the whole theory together.
Yeah.